Well, thank you, Walter. It's always amazing to be part of Walter's bonanzas, I should say. And if you know that Samya is involved, you also know it's very well organized. So I'm very happy to be here. So I'm involved in robots, and particularly the little creature that you see there on the right, who never does what he has to do. Because working with robots, you know, is actually very difficult. And I'm personally not so interested in doing utilitarian things with robots, although I think it's, of course, good that some people do it. But for me, it's more a platform. It's a kind of tool for experimentation. And so it's a bit like the Wright brothers who have been building, you know, airplanes of all sorts in order to develop a theory of aerodynamics. And then, of course, they had lots of applications, but we also need to develop theory for building intelligent systems or for arriving at intelligent systems. Now, to give you a little taste of the kinds of things that we do in our lab, I'll show you first a video clip here. Now, this is this okay? This is one of our robots, and you see we give it a mirror and we let it look in the mirror, and the robot sees itself. Now, for me, the singularity would be if the robot then says, "Is this me?" And of course, when you see this video clip, I should say it doesn't happen yet. Okay, but it is a vehicle, a framework in which we can investigate many questions that philosophers are also interested in. For example, attention, awareness, self, empathy, intersubjectivity. Can a robot have all these things? And if so, how? And what is involved? What about meaning and intention? What about insight, problem solving, insightful learning? And then language, of course, which is the thing I'm mostly interested in. So in order to investigate these things, we need an hypothesis. And the hypothesis that we are exploring is that the explanation for all these things doesn't come from the material properties of the brain. Okay, you might think, like Penrose, for example, that there's some special properties of our neural networks, maybe quantum gravity or something like that. And so if we could master that, if we understand it, we put it in a computer, then this computer will have all these properties which are on this slide. Now, I think this is not the right approach. Instead, I believe that the explanation and also technologies will come from understanding networks. Networks, I mean very complex connections between concepts, sensory experiences, motor control, words, grammatical constructions, thoughts, all sorts of things. So we're talking about giant networks that form in our brain that are completely dynamic, changing all the time. And not just in our brain, but it's also connected to our body, which is also generating all these networks between our sensory apparatus, our motor system. And then it's not just ourselves, you know, as an individual, but I think all these properties like intersubjectivity and so on are due to networks that are across different people. So if we're trying to understand these things and use robots for that, we also have to see how we can grow these kinds of networks, how we can set up systems so that these networks start to grow a little bit like the internet or the World Wide Web, where you always have new things, new connections being made, and so on. Now, let's see how we can investigate that. So one of the things that we do is set up our robots in such a way that they play language games. And a language game is, I'll show you a little clip of it. Okay. Maybe it's nicer to see on a full screen. Okay, so a language game between two robots, they are in a shared environment, which we set up. And both of them are looking around to find objects. And then one of them is taking the initiative and going to say something. And he says, "Bolima." Now, what could Bolima mean, right? Now the other one is looking around and points to an object that he thinks might be Bolima. Then the other one is looking, and we can see actually what they are seeing, is looking to see whether this is Bolima. I said, no, this was not Bolima. And then he's pointing to the object that is Bolima. Now, something magical has happened here. It's not just the interaction itself, but what is going on is that these robots, and I'll show you another example of a successful game in this time. You know, what these robots have to do is, of course, first of all, they have to perceive their world. And here you see on top, you see on the left and the right, this is what the left and the right robot are seeing. And on top of that, you see the world model that they're building up. So they have to get out of this stream of mass of visual data, they have to get a picture of the world. And very important here is that each robot is seeing their own thing. They never see the same thing. They see the world from different points of view, but they nevertheless have to try and communicate and try to use language in such a way that the other one would understand it. So this is already magical, I think. But what is more is that in our experiments, we do not give these robots a vocabulary to start with. They have to invent their own vocabulary. We even don't give them concepts like left or right or front or back. They have to come up with these concepts themselves. And why do we do that? Because it's only when we figure out in some sort of way how these robots can, generate their own communication system, come up with their own concepts, that I believe that we can really call them intelligent. Now, I was talking about these networks, and I'll show you just an example of a network in a single agent. So now we're looking in the brain of a single robot as it is playing these games. Because what we do actually is we have a population of robots, and these the robots themselves, well, they are agents which are stored in a software state, and every time they play a game, the state is downloaded into the body of the robot is doing an interaction, and after it, the software state is uploaded again. And we have a teleportation facility that we can have these agents travel over the internet in search for bodies, download into a body, play a game, and that can happen in Tokyo or in Paris or wherever. So this is a peek into the networks that one agent is building up. And you see here sensory experiences. These things are prototypes that they are using to make sense of the world, kind of image schemas that they impose to understand or to categorize the world. And here the blue ones are the words that they have. And as you can see, this network is dynamic, is ever-changing, new nodes are being made, new connections are being made, and that's what I really mean when I say the explanation is in the network, it's those kinds of networks. I will quickly give another example, which is games that we do with our robots in order to learn about actions. Because obviously we want to be able to communicate them what we would like them to do. And in this particular game, one robot is asking something from the other robot. And if it's not what he had in mind, then he will show what action the other one had to do. And again, there are networks involved that will be built up by these different agents, and here's a little peek of them. So I have to conclude here now. Basically, what I'm saying is that if we want intelligent robots able to deal with language in a creative way, deal with the concepts underlying language, the words and grammatical constructions, well, they have to be able to invent. And what they have to establish for themselves are these networks such as the ones that they see. And this is not a one-off thing, it will not happen in one flash. It is happening in a lifetime, and it's changing all the time, building up in complexity. Thank you very much.